Hello, RedMars explorers, and welcome to the grand finale of our 10-episode special on the basics of space systems. It's been an amazing journey so far, covering everything from robotic explorers to space stations. Today we're taking our imaginations and science to the next frontier. We're talking about Mars and beyond. But first, I want to give a huge thank you to all of you, our listeners. I know we just started out and there's not too many just yet, but we hope to grow and get more of you involved. So your support has been incredible, and I'm thrilled to share with you what's next for the RedMars Podcast. More on that at the end of today's show, though. So for now, strap in, because we're diving into the future of human space exploration. We'll explore how humans will get to Mars, what they'll need to survive, and what it could look like to build a Martian colony. And for some extra fun, we'll speculate a bit about what lies beyond Mars, deep space travel, interstellar missions, and much more. So, let's start with getting to Mars, the journey. Let's start with the basics. How do we get to Mars? A mission to the red planet is no small feat. Mars sits on an average of 140 million miles from Earth, and travel times depend on the alignment of the two planets. A one-way trip could take anywhere from 6 to 9 months, depending on the propulsion systems used, of course. So, what are some real-world technologies that, could get us there? Well, let's look at some spacecraft. NASA's Orion capsule and SpaceX's Starship are the frontrunners. Starship, in particular, is designed to carry large crews and cargo, making it a game changer for missions to Mars. The propulsion, well, they use chemical rockets. Like those used today, they are sufficient for the trip, but advanced propulsion systems such as nuclear thermal propulsion is much faster and more efficient, or even ion propulsion could drastically cut travel times in the future. But there are some challenges along the way. Radiation. Yes, we've mentioned this quite a few times on this channel, so we'll continue to go with it. So, radiation. Space is full of cosmic rays and solar particles that could harm astronauts over long durations. What are the solutions? Well, solutions include protective spacecraft shielding, or even water-lined cabins. Yeah, that's possible. There's still some more we need to go into that, and I really think this is a good topic to touch a bit more on in the future, so definitely stay tuned for that. Psychological stress. Imagine being stuck in a metal tube with your crewmates for 9 months. That's why training and advanced life support systems are crucial. The technology is advancing, but the journey to Mars will require more than just rockets. It will demand the courage and resilience of astronauts on board. Think of just a few years ago, during COVID and that pandemic. We were forced to stay in our homes. How many of you, with roommates or maybe even significant others, got on each other's nerves? Now imagine, even in the wildest conditions, you're stuck together 9 months, a year, maybe even longer for those long duration missions beyond Mars. So that's why I think for these long duration missions, we have to think a bit more beyond just what skill sets do these individuals have that are going to be bringing, to the table as they make their way to Mars, or maybe their age or anything like this. But we have to also look at their personalities and almost do a personality test and see which individuals have the possibility of having the greatest success rate together, rather than just throwing whoever's willing in a pile and say, hey, go to Mars, because you might find that people are at each other's throats a lot sooner than expected. But anyways, let's kind of look at what this means then, and what about surviving on Mars? So landing on Mars is only the beginning. The red planet is a harsh environment with an average temperature of negative 80 degrees Fahrenheit, a thin carbon dioxide atmosphere, and frequent dust storms. So what do humans need to survive? And for those that don't know Fahrenheit or are on the metric system, that's more so closer to say 30 degrees Celsius, just give or take. So shelters. Well, shelters are going to be a difficult thing to build on Mars, not only just because of the environment and getting those supplies there, but you have the radiation environment and everything like that. So Mars shelters will likely start as prefabricated habitats sent ahead of crewed missions. These will be pressurized, insulated, and potentially buried underneath the Martian soil, or we like to call it regolith, to shield against radiation. So, fun fact, I did a project in my master's and we had to design a roof for a shelter on the moon using the lunar regolith, and we had to determine what thickness was required and then design the beams that would support that thickness of lunar regolith. and it was found to be approximately 3 feet in depth, close to 1 meter, in order to shield those astronauts safely so that they would not receive a lethal dose or accumulate lethal dosages of radiation on the moon. So just a cool fact there. But same thing here on the Mars surface is you could use the Martian regolith to shield against that radiation. So companies like SpaceX, Blue Origin, and NASA have explored the use of 3D printing to construct habitats using Martian materials. Cool. What about food and water, though? So, transporting all the food and water needed for a colony just isn't feasible. Future settlers will need to grow crops in controlled environments like hydroponic and aeroponic farms. Extracting water from subsurface ice deposits will be a top priority. Mars has polar ice caps and underground reservoirs that could be used to sustain human life. Then that brings us to energy. All these things will require energy, so solar power will be critical, but dust storms could block sunlight for weeks. Nuclear power, such as compact fission reactors, is a reliable alternative. Perhaps we'll have fusion reactors that are more portable at this time when we're actually making that trek over to Mars. We will see, though. It's also probably a good topic to touch on. I've seen some other speculative technologies out there that could be fun just to speculate with on how that could help us for some of these colonizations and deep space missions. Alright, so fun fact, NASA's Perseverance rover is already testing MOXIE, a device that extracts oxygen from the Martian atmosphere. Imagine future astronauts breathing Martian-made oxygen. That would be pretty cool, and that's all about that in-situ resource utilization and being able to do these electrolysis processes that, you can use oxygen or take the hydrogen for fuel and so on. So we'll definitely talk more about that in the future. So colonizing Mars. Once survival is ensured, the next step is creating a thriving Martian colony. But what exactly would that look like? What is thriving on Mars? Well, we need to start with some sort of infrastructure, so building a self-sustaining Martian colony is no small feat. It will require a robust and interconnected infrastructure to ensure survival, productivity, and even comfort for its inhabitants. So, transportation. We mentioned before that rovers and that move pretty slow because they require either some predictive AI to avoid the long duration of round-trip commands being sent to them. That would require then human in the loop, and they just don't move too fast. But transportation, once you're there, how would that look? Would you ride around on a rover? Or maybe a train? So, on Mars, movement across the planet's dusty and rugged terrain will definitely depend on a variety of vehicles. Advanced rovers, equipped with autonomous navigation systems, will be essential for scientific missions and cargo transport. But over time, high-speed rail systems or Hyperloop-style maglev trains, and that's magnetic levitation, could connect major research hubs, enabling the efficient movement of people and materials across longer distances. Energy solutions. So we kind of talked about atomic power and solar in that, but what else is there? So colonies will need reliable and renewable energy sources. Solar panels, while effective here on Earth, face many challenges on Mars due to frequent dust storms. This is the same on the lunar surface. The dust is extremely fine and manages to get into nooks and crannies that, Earth soil and dust doesn't quite do the same. So, to overcome this, scientists are exploring several technologies. Nuclear fission reactors. So compact and reliable, these could provide steady energy for habitats, vehicles, and life support systems. Now that does also come with all the, negatives that come along with fission reactors specifically, not just nuclear power. Nuclear power is a great resource, so I don't want anybody blowing up the comments on that one. That is, very pro-nuclear. I am also pro-nuclear, but I think fusion is definitely a better solution once we get to that point. So for the meantime, fission reactors, I think, are the best possible solution for this types of power, but we would have to have a better understanding of how we're going to dispose of any type of waste, because we don't want to start polluting a planet right when we get to it. And just launching it into space is going to require power on its own as well, so we'll see what that looks like. Anyways, moving forward. So, NASA's Kilopower project is an example of a system designed for this purpose. Go check it out. Geothermal energy. Though Mars has no plate tectonics, that's right, there's no shifting of plates or anything like that, like we do have here on Earth, but it may have residual heat in its core that could be harnessed in certain regions. Then there's wind energy. While the Martian atmosphere is thin, high-speed winds during dust storms might still be used to generate supplemental energy. What about water management then? So water management systems. Water is critical not only for drinking, but also for farming, industrial process, and generating oxygen through electrolysis. Ice deposits at the poles and below the surface in certain regions could be mined and processed. Advanced recycling systems, similar to those used in the ISS, will ensure that water is reused efficiently. Back to radiation, shielding, and safety. We talk about radiation a lot. That is a major factor in space, so you'll definitely hear us talk about it many times in the past, current, and in future episodes. So, Mars lacks a magnetic field, exposing its surface to high levels of cosmic and solar radiation. To protect colonists, habitats must be built either underground or covered with several meters of Martian regolith, made from advanced materials infused with radiation-absorbing properties like hydrogen-rich polymers, or equipped with energy or storm shelters where colonists can retreat during solar radiation events. Agriculture and food production. Growing food on Mars will require controlled environments like greenhouses with artificial lighting and soil conditioning. Scientists are experimenting with ways to use the Martian regolith as a growth medium supplemented with nutrients. Vertical farming and hydroponic systems could also play a key role in providing fresh produce. I've seen them do some of this on the space station, and it's really cool to see how these plants grow in a microgravity environment. Though Mars is not microgravity, just wanted to point out that these systems are currently being tested and used in space. Now onto something a little bit different that probably most don't think about: the economy. What will the economy on Mars look like? So the economic framework of a Martian colony will evolve as it grows, as it does anywhere we've seen on Earth. But moving from a survival-based system to a more diversified economy, what does that look like? So let's speculate a little bit here. Early stages: research and sustainability. Initially, the colony's economy will focus on self-sufficient and scientific research. Activities like mapping the Martian surface, conducting experiments, and developing technologies for long-term survival will definitely dominate. But then will come resource mining and trade. So over time, industries will emerge to exploit Mars. Natural resources and say water. So such as extracting rare metals like titanium or platinum from the planet's crust. These materials could be used to support the colony or even exported back to Earth, potentially sparking an interplanetary trade network. I'm trying to remember, I think the show's called For All Mankind. I watched it on Apple TV, and this isn't a plug or anything, but it is a great show. I believe this is similar to what happened on Mars. They started off with research and that with a colony on Mars, and then the companies that were there realized that there were some rare metals and that, and then there was an asteroid that was coming by that they were going to mine, and then they decided to revert that asteroid to Earth rather than Mars, which would then more or less shut down the economy on the Martian planet, and people fought back, and it was this crazy episode, and I guess several episodes, but the show was fantastic, so definitely give it a watch if you haven't, but this just made me think of that and how it came crumbling to the ground due to greed. So yeah, you'd think we learned from our mistakes in the past, but history usually or always repeats itself. Alright, so what about a Martian currency? A unique Martian economy might need its own form of currency. Rather than physical coins, a blockchain-based digital currency could be implemented, ensuring secure and efficient transactions. This system would also allow for easy integration with Earth's economy, creating a unified interplanetary financial framework. Tourism and cultural development. Imagine Martian tourism, Earthlings visiting the red planet to experience low gravity, experience ancient riverbeds, or stay in dome-like resorts under Mars's dusty skies. Over time, colonies may develop their own culture, art, music, and traditions, adding another dimension to their economy and identity. Thrive, not just survive. Ultimately, the goal of Martian colonies is not merely survival, it's thriving. Colonies will need systems that foster innovation, education, and well-being. Schools for children, entertainment hubs, and even scientific conferences held on Mars could make the colony not just a workplace, but a home. there are so many sci-fi films going through my mind as I give this episode. You know, everything from the 100, where they formed tribes back on Earth after the wasteland that it had become, and just thinking how they started trading and I wouldn't say thriving, because it was pretty violent, but yeah, we won't get into it. But definitely gets me thinking. So definitely, if you have an imagination, I hope you're enjoying this episode and thinking through what possibly an economy or colonization of Mars could possibly look like. And I'd love to get some comments as well about what you think a colony on Mars could start out, evolve into, and then ultimately become, and get your thoughts on that. So definitely interested. Anyways, let's continue on here. So this is humanity's opportunity to build a society from scratch, one that incorporates the lessons of Earth, but also dares to dream bigger, creating a new chapter in human history, which is ultimately, I believe at least, Elon Musk's idea of colonizing Mars, saying that we have to become an interplanetary species. Now, I haven't heard many mention what that interplanetary species would sound like in the future once we move past that initial, survival mode of trying to make things work. Once things work, then what? So that's the kind of question we're trying to speculate some sort of answer to in this episode. So definitely a fun one, and I encourage you to think about it as well and think what you could maybe come up with. Anyways, what happens beyond Mars? Well, deep space dreams, interstellar coming a reality. So now let's really let our imaginations soar. What's beyond Mars? So the outer solar system, Jupiter's moon Europa and Saturn's Enceladus. We've talked about these several times, so let's continue with them. They're intriguing targets with a subsurface ocean that could harbor life. Missions like Europa Clipper are already in the works to explore these icy worlds. Interstellar travel. Here we go. If we want to reach other stars, we'll need breakthroughs in propulsion. Like light sails powered by lasers and antimatter engines, projects like Breakthrough Starshot aim to send tiny probes to Alpha Centauri at 20% the speed of light. Now, I'm really intrigued with alternate propulsion and stuff like that, and even with wormholes and gravity as a whole. Maybe I've watched too much Interstellar and sci-fi movies, but if we could find a way to manipulate the gravity around us, and rather than soar through space, but move space and time around you, I believe it would appear you're moving faster than the speed of light. Although you're not really, you're just moving space and time around you rather than moving through space and time. So it's not really the same thing. So it's not going to be able to explain it on this show, but something to think about. Curious about what your thoughts are on that one. Anyways, sci-fi futures. Could we one day build massive generational ships where humans live and work as they travel to distant star systems? Or what about these wormholes I talk about? While purely theoretical, they're a tantalizing possibility for instant interstellar travel. The future of space travel is as vast as the universe itself, and it's up to us to explore it. So, these purely theoretical wormholes, I believe, have actually been proven at a very small scale here on Earth all around us, and only lasting for microseconds at a time, even quicker than that. But the idea of a wormhole is that you have one point in time, or one point in space, and then another point of space somewhere else, and this wormhole allows you to, in quotes, step through, and then you're immediately at the other place. So think of it, I've seen these demonstrations of gravity and what gravity looks like by holding a sheet, and you put a weight in the middle of the sheet, and picture that as a planet or a black hole or something like that, and that everything is drawn towards that section. Now, if you could cut a hole on the left side of that sheet and then cut a hole on the right side of that sheet and then bend it so that those two holes meet, that is what a wormhole is. You're traveling from one side to the other side, and now all of a sudden you're on the other side of that mass. That's a wormhole. Theoretical, but I do believe they exist in nature, and I do look forward to future research in that area and seeing what comes from it. So, anyways, conclusion. So, that was quite a journey through space and time. Yes, absolutely. And I hope you enjoyed thinking just what it might look like for a colonization of Mars. And we can definitely dive deeper into this. But like I mentioned, we want to dive into specific technologies moving forward rather than just basics as a whole or the entire system of a Martian colony. Maybe we could look at just the economy, or maybe we could look at just those structures that you would need, or the power systems, or something along those lines. We'll figure it out. But yeah, moving forward, that's kind of what we're thinking. So, from surviving on Mars to dreaming of interstellar travel, we've explored humanity's boldest ambitions through these past 10 episodes. So, as we wrap up this 10-episode special, I want to thank everyone again for joining me on this journey through the basics of space systems. But don't worry, the RedMars Podcast is far from over. This is just the very first section to get everyone kind of introduced to how I deliver, I guess, these technologies and what these technologies actually are and the basics that go into them. So this is kind of laying the groundwork that'll help those listening better understand the systems we're going to talk about in the upcoming episodes. So starting next week, we'll transition to a weekly episode basis, so diving deep into specific topics. We want to learn more about, say, lunar habitats or asteroid mining. That is what we're going to dive into, the specifics of that one technology. Or maybe we'll even dabble in science behind the exoplanet detection. Who knows? But we will cover it all. Now, where we start, nobody knows. So subscribe and stay curious, because the future of space is brighter than ever, especially in today's times. And on that note, actually, I just want to mention one last thing before we call it out today. The Starship 7 launch. Unbelievable. So, way to go, SpaceX, on your second capture of the booster with the chopsticks. That is absolutely an amazing success. Now, what happened to the actual Starship, I'm not sure, but the footage that has come out from all the I guess, over the Caribbean or the Bahamas, I forget, I think it might have been Turks and Caicos, actually. But the footage that we've been seeing of the Starship's beautiful colors as it blows apart in the sky, absolutely incredible. And it goes to show that all these space companies that are currently in existence and coming to light, and we're all pushing the limits of space technology, and that's how we're going to have these giant leaps and advancements in technology. So I love seeing it. Obviously, I wish it didn't explode and it had a much more successful flight, but with every failure comes some sort of data that can help us improve and move forward and be more successful in the long run. So way to go, SpaceX. Keep up the great work, and looking forward to the next Starship launch. So as I mentioned, definitely subscribe, follow along on this podcast if any of this interests you, and if it doesn't, well, follow along anyways, because maybe it will. So with that, until next time, stay curious and keep looking up. Take care, everyone, and I hope you have a great rest of your week. Until the next episode, see you then.